Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello, guys, and welcome back to this amazing channel, Geeks for Geeks Practice. This is Abhinav, and today we are back with our next problem of the day, which is nothing but Santa Banta. Actually, it's a quite complex problem based on the graph concept of DFS. So let me first open that what the problem states. Okay, so please, first of all, please let me know if I'm clearly visible and audible to you all, so that we can start. Am I clearly visible and audible to you all? Okay, okay, great, great. So that's the basic thing. Let me share the screen and start our today's class. So, hello Joel, hello Victor, hi Reset. See, what the problem says here is that you are given with a Santa and there are n girls given to you, okay? And for every girl, you are given with some connection, okay? And then you have to find the kth prime number where k is the largest group of girl you know each other. So basically the thing is that there are some girls and the connection between their girls are given. Let's say n is 10, m is 6, means there are 10 girls, out of it the 6 of them have connections, means let's say this is the first girl, second girl, third girl, fourth, fifth, sixth, seventh, eighth, nine, and 10. Now there are six connections between them, between 1 and 2, between 2 and 3, between 3 and 4, 4 and 5, 6 and 7, 9 and 10. So you can see this is the connection given to you. So it is something similar to a graph. It is something similar to a graph. So you have to find the girl with maximum number of connection, with maximum connection, and which is equal to k. Then you have to find the kth prime number. Let's say the prime numbers are like this. The prime numbers are 2, 3, 5, 7, 11, 13, and so on. to find the kth prime number. Okay, so like in this particular yeah, Joel, this is very consistent actually. Yeah, so yeah, you can see here that you have to find the kth prime number. So in this particular case, you can see that this particular group is having maximum connection 5, and fifth prime number is 11. So 11 is the answer. That's the basic case. That's the basic problem. So basic thing is, guys, if you will see, like if one is having connection with two is having connection with three, then one is also having connection with three. That's the basic case. And you can see here it's written here. If A knows B, B knows C, then A also knows C. And according to them, A one is a composite number, we are not giving that. And this pre-compute function here is basically used to pre-compute the value of prime number using Siebel algorithm. Okay, that is used for a Siebel algorithm. Is it fine? Is the problem clear, guys? Problem clear? Okay. Not guys. The problem is simply that you have n. What is n? N is number of nodes. You have m. M is number of edges. Okay. Then you have some m pairs denoting each edge. And from after that you have to find the component with maximum node, or I can say the largest component. Just like here it is 5, whose value is k. And then you have to find the kth prime number. This is the basic step. इतना आपको करना है. You have to do this much of thing in this particular question. And for counting the component with maximum number of nodes, I will use the DFS algorithm. I will add how many nodes that particular have. So let's see how we can do it. So first of all, guys, we'll be using this pre-compute method to pre-compute the value of the sieve. So the prerequisite of this problem is the sieve algorithm, and I hope that everyone knows about the sieve algorithm. I hope so. I think so. Okay. So sieve algorithm में क्या होगा? Like what will happen in this sieve algorithm? Let me check the driver code also. Yeah. तो sieve algorithm में क्या होगा? We will have here vector, let's say vector of primes. Okay, and this primes vector will contain all the prime numbers. Okay, this primes vector will contain all the prime numbers. So just like what we do in like C algorithm, if you remember, that we take a particular boolean and we consider all of them as true. Okay, so I will have here a vector, a boolean vector of size n plus 1 actually, but here let's you can see that it is up to 10 to the power 5. So we will count pairs up to 10 to the power 5 only. Okay, so you will have a prime vector of size 10 to the power 5 plus 5, let's say, and initially I will take all the vectors at as 0 true. Initially in C algorithm we assume as true. Okay, fine, all of them. Now what do we do? We know that 0 is not a prime. I will make it false. And we know that 1 is not a prime. I will make it false. Now for all the numbers starting from 2 till, if you remember, we go up to square root of n. So square root of this value that we're having. Okay, I will go on. For multiples, if that is already prime, if that is already a prime, now what I will do, I will take the multiple of that number. So this is nothing but the C algorithm. I will take the multiple of that number and I will make it false. I will make it false. At the last, for all the numbers, for all the numbers, for all the numbers, if a number is prime, if a number is prime, I will push it in that primes vector. Guys, this is how this particular problem works to find the array of prime numbers. And now using this array, what we will do? Using this array, we'll find the आशुतोष एक्चुअली जो sieve है ना, we have to use this sieve for every test case, or I can say every time you have to find the kth prime number. तो बार बार उसको कंप्यूट करने से अच्छा क्या है, एक बार प्री कंप्यूट कर लो और हर बार उसको यूज करो. अब तुम हर बार प्राइम नंबर को कंप्यूट करोगे, कैलकुलेट करोगे, तो कोई मतलब नहीं ना उसका. आप एक बार निकाल के रख लो, प्री कंप्यूट कर लो, तो ये प्री कंप्यूट फंक्शन एक बार चलेगा. बात समझ में आ गई आशुतोष? फाइन, ठीक है. अब देखो, नाउ गाइस व्हाट आई विल डू, नाउ वी हैव टू परफॉर्म हियर द डीएफएस फंक्शन. ठीक है. अब देखो डीएफएस फंक्शन में क्या होता है, वी यूज अ विजिटर एरे इन डीएफएस फंक्शन. ठीक है. तो हम लोग यहाँ पर एक विजिटर एरे ले लेंगे. आई होप इट्स फाइन. ओके. तो हम लोग यहाँ पर एक विजिटर एरे ले लेंगे. वेक्टर इन विजिटेड, वैसे तो बूलियन होता है, and of size n plus 1 comma false. So initially the visited is false, means initially we are assuming that that visited is that all the elements are not visited. Okay. And we have to find a value of k. So I will assuming k as 0 initially, means we have to find the kth prime. Na? So k is the largest connection. So currently I'm assuming my connection as 0. Okay. Now I, for all the girls from 0 to n, for all the girls from 0 to n, okay, if it is not visited yet, if it is not visited, we will call the DFS for it. We will call the DFS for it. DFS for that particular girl with that particular graph. Graph is given to us. Okay. And the maximum of that DFS, like I will take the max now. The maximum of that DFS will be stored in this K. So this K is the largest connection. Just like here, the largest was 5. That K will contain the largest connection. And then at the last, we will return the kth prime number. We will return the kth prime number. Also, what they are saying, there is one more thing here. The thing is that if a girl only has one connection, so output should be -1. So like if this k is equal to 1, you will return -1. Else you will return the prime number at k, the kth prime. एडजेसेंसी मैट्रिक्स से यार कोई डिफरेंस तो नहीं होता आशुतोष, आप कैसे भी करो. और यहाँ पर तो आई थिंक आपको कुछ भी बनाने की जरूरत नहीं पड़ेगी, बिकॉज आपको डायरेक्टली दिया गया है, आई गेस नोट्स दिए गए हैं ना आपको. सो आप लाइक एडजेसेंसी मैट्रिक्स बनाना पड़ेगा. बट इसमें ये है ना कि हर गर्ल के लिए दिया गया है ना. आई गेस आपको सिमिलर टू मैट्रिक्स ही दिया ही गया है. 2D matrix of Gauss connection. Yeah, G appears to be only have edges. Exactly. G में तो सिर्फ edges ही हैं. ओके, तो हमें इसको एडजेसेंसी लिस्ट या फिर एडजेसेंसी मैट्रिक्स में कन्वर्ट करना पड़ेगा. आप बोल रहे हो मुझसे आशुतोष की इसे एडजेसेंसी मैट्रिक्स बनाओ. यू वांट मी टू मेक इट अ एडजेसेंसी मैट्रिक्स ना. वेट, लेट मी चेक. एक बार मैं चेक कर लेता हूँ. ओके, नहीं नहीं नहीं, आप एक चीज देखो गाइस, आप एक चीज देखो. सी सोनू, यू कैन यू सॉल्व डिवीजन. हाँ देखो, यूनियन फाइंड से कर सकते हैं, बट यूनियन फाइंड भी कॉम्प्लेक्स हो जाएगा. आप लोग एक चीज देखो यार. इफ यू विल सी द ड्राइवर कोड ना, ड्राइवर कोड में उन्होंने एडजेसेंसी लिस्ट दी हुई है. यू कैन सी हियर. ठीक है, तो आपसे बोला जा रहा है जस्ट लाइक दिस, बट एक्चुअली में यहाँ पर आपको एडजेसेंसी लिस्ट ही दी गई है. दे हैव कन्वर्टेड दैट फॉर यू गाइस. यू कैन सी हियर. ओके, यू कैन ओपन अ ड्राइवर कोड एंड यू कैन सी यहाँ पे एडजेसेंसी लिस्ट दी गई है. So now it becomes very easier for you. Now you can directly write the DFS function using the adjacency list. And we know that DFS is very easy using adjacency list. Okay? It's not edge. You can see here in the driver code. It's adjacency. Like वो G में से क्या कर रहा है? From that G, it is extracting and in every value it is pushing back. So वो जो है ना वो ड्राइवर कोड में ही they are converting. So actually the statement is quite. यहाँ पे एक चीज और है कि kth प्राइम में k माइनस वन इंडेक्स जानी चाहिए ना, इफ यू वांट kth प्राइम. इज इट क्लियर? ओके, सो नाउ डीएफएस फंक्शन में क्या होगा ना कि वी विल बी हैविंग द डीएफएस फंक्शन जहां पर आपके पास बेसिक देयर विल बी three things. One is the t, sorry, I, the current index where we are. Next is that adjacency list only, the list, and next is the visited matrix that we have taken. So this is the visited matrix. You will take this also. Okay. Now after that, what you will do is, first of all, you will make visitor of I is equal to true. Okay. Then you will currently take your count as one. Count as one means that currently you are assuming that particular element in the array only. Okay. Now for all the adjacent element of that particular node, so we are currently at I, you have an adjacency list. So for every x which is adjacent to that I, you will check that if it is not visited, then what to do? If it is not visited, that x, just a minute. Yeah. So if it is not visited, then you will again call the BFS for that, and you will add its value in the count. At the last, you will return the count of the nodes connected to it. That is what you have to follow. And finally, the maximum of all the nodes will be stored in this k, and then at the last, the kth prime number is printed. That's the basic thing what we are doing. So ये क्या प्रॉब्लम आ रही है? इसमें कुछ प्रॉब्लम आ रही है क्या? Yeah, like we are maintaining the maximum of each. नहीं नहीं, काउंट प्लस प्लस नहीं होगा, काउंट में उसका अगला डीएफएस ऐड हो जाएगा। वो बिल्कुल सही होना चाहिए यार। वो तो सही हो रहा है। के क्या आ रहा है इस केस में? काम करते हैं, के को रीडिंग करके देखते हैं कि के क्या आ रहा है। लाइक के शुड बी 5। अच्छा, सो के तो सही आ रहा है यार। लाइक इसका मतलब जो प्रॉब्लम है ना वो हमारे यहाँ पर है, प्री कंप्यूट फंक्शन में प्रॉब्लम है। प्रॉब्लम दैट वी आर हैविंग इज इन प्री कंप्यूट फंक्शन। एग्जैक्टली एग्जैक्टली। नहीं 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 आशुतोष, के इज फाइन। ओके, के इज फाइन, मैंने देख लिया। सो द प्रॉब्लम इज इन दिस प्राइम्स वाला एरे। क्या प्रॉब्लम है? आई एम नॉट गेटिंग दैट। Let's check it out. Okay, we have to make this prime of j is equal to false. There was a single problem. I was making primes of I is equal to false here. It should be primes of j equal to false. Yeah, it got it run. Okay, so I'm getting wrong answer at the very last case. Your code output is this and correct output is this. Okay, so I have to found the prime numbers more than this, up to 10 to the power 6, let's say. I have to find prime numbers up to 10 power 6, let's see. Yeah, now it's fine. Okay, you can see it's submitted successfully. So I think the time and space complex is something similar to that. By the way, we are also having this, which is order of. So you can see that the time complexity for this sieve is nothing but order of n log n. But now BFS will take n plus m, something similar to that. Okay, so that's the basic. Yeah, the correction was very basic. Like in here in play here we have to make prime of j is equal to false. Na means for multiples we make it false. But I was making prime of I is equal to false, so that was the problem. Okay. Okay, guys. So I hope that now it is clear. I know still that the problem was quite complex, but yeah, finally we solved it, and it was a great, good problem actually. But just one suggestion for the problem setters to make problem more clear to understand. The problem statement was not much clear. Okay, what I see. Okay. This is actually we have to calculate number of primes equal to the maximum value of k, because we have to find the kth prime. So we can get that what can be the maximum value of k that we can get. So maximum value of k means if even if all the uh, all the like everyone will be connected, then also the maximum number of k will be up to this only. This. That is why I've taken it up to 10 power 5. But because of some reason it was giving overbound in 10 power 5. So I've taken 10 power 6. Okay, that's the basic. So I hope that we have got it. Okay. So great. Let's again meet tomorrow with the next problem of the day. Till then, thank you. Happy coding. Good night. GFG कर लो हो जाएगा.